Hello and welcome back to our continued study of trigonometry. In this next section, we're going to learn about right triangle trigonometry. So in the first section, we learned about radians and degrees and how to work between the two. In the second section, we learned about the unit circle and how it relates to the trigonometric functions. Today, we're going to learn about those same 6 trigonometric functions, but how to use them with right triangles. By the end of this lesson, you should learn how to evaluate trigonometric functions of acute angles, use fundamental trigonometric identities, and use a calculator to evaluate these trigonometric functions. The 6 trigonometric functions. We've already looked at the unit circle, and now we're going to look at the right triangle. So here's the right triangle perspective. So if you look at this right triangle here, there's one acute angle that's labeled theta. That is your reference angle. And based on this angle, there's a side opposite, there's a side adjacent, and there's a hypotenuse. These 3 values of the lengths of these sides can be used to find all 6 trigonometric functions. So, just like I said, relative to the angle theta, the 3 sides of the triangle are the hypotenuse, the opposite side, which is the side opposite of the angle, and the adjacent side, which is the side adjacent to the angle. Using the lengths of those 3 sides, you can form 6 ratios that define the 6 trigonometric functions of the acute angle. The 6 functions are sine, cosecant, cosine, secant, tangent, and cotangent. It is important to see that it has to be an acute angle, so from 0 to 90 degrees. So the theta lies in the first quadrant. The last section, we talked about how an angle could land in any quadrant. For this specific lesson, we're going to think of them just in the first quadrant. All the trigonometric functions are going to be positive because all the sides of the triangle are positive. The right triangle definition of trigonometric functions. If theta is an acute angle of a right triangle, then the 6 trigonometric functions of the angle theta are defined as follows. Note that the function in the second row are the reciprocals of the corresponding function in the first row. So a lot of times when I'm working on problems like this, I'll do sine, cosine, and tangent, our basic ones, and then I'll find the other 3 by flipping the sine, cosine, and tangent ratio. So sine, opposite over hypotenuse, where cosecant is hypotenuse over opposite. Cosine is adjacent over hypotenuse, where secant is hypotenuse over adjacent. Tangent is opposite over adjacent, where cotangent is adjacent over opposite. The abbreviation OPP, ADJ, and HYP represent the lengths of 3 sides of the right triangle. So the opposite, the adjacent, and the hypotenuse. So using these 3 sides, you can find all of these ratios. Here's an example. We're given a triangle here that has 2 sides. It gives us 3. It gives us 4. We don't know the hypotenuse, but because it's a right triangle, we can use what we know about Pythagorean theorem to find it. So a squared plus b squared equals c squared, or the opposite squared plus the adjacent squared equals the hypotenuse squared. So the hypotenuse ends up being the square root of 4 squared plus 3 squared, which is equal to the square root of 25, or just 5. So we know this hypotenuse is 5. We cannot find all 6 trigonometric functions unless we know all 3 sides. So the 6 trigonometric functions of theta are sine of theta is opposite over hypotenuse. So here's our angle here. Opposite is 4. Hypotenuse is 5. Cosine is adjacent over hypotenuse. Adjacent 3. Hypotenuse 5. Tangent is opposite over adjacent. So opposite is 4. Adjacent 3. You get 4 over 3. Now you can use the triangle to do the other 3, or look at the relationship. So cosecant is the reciprocal of sine. So cosecant is hypotenuse over opposite, so 5 over 4, or you can take the sine ratio of 4 over 5 and flip it to make 5 over 4. Same thing with secant. So secant would be hypotenuse over adjacent, or 5 over 3, or you can take the cosine ratio of 3 over 5 and flip it to be 5 over 3. Cotangent is adjacent over opposite, so 3 over 4. You can use the right triangle, or you can go to the tangent and get 4 over 3 and flip it. Trigonometric identities. Trigonometric identities are made to help you. A lot of times students, when they first see them, they think they're more confusing. Trigonometric identities are for you, and they are to help you understand trigonometry better and make some problems that might be a little complicated simpler. The first 6 identities are the reciprocal identities that we have already mentioned. So cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. Just as sine is the reciprocal of cosecant, cosine is the reciprocal of secant, and tangent is the reciprocal of cotangent. Some that we did not talk about yet are the quotient identities. Tangent is equal to sine of theta over cosine of theta, and cotangent is equal to cosine of theta all over sine of theta. The Pythagorean identities, we know that sine squared of theta plus cosine squared of theta is going to equal 1. 1 plus tangent squared of theta equals secant squared of theta. And 1 plus cotangent squared of theta is equal to cosecant squared of theta. We will use them so much that I believe that you will be able to memorize them. One thing to note is that sine squared of theta represents the whole sine of theta squared, and that cosine squared of theta represents the whole cosine squared of theta. It's not just squaring the theta, it's the whole value of sine of theta squared and the whole value of cosine of theta then squared. Here's an example of using a Pythagorean identity. Theta is an acute angle. Sine of theta is equal to 0.6. So find the values of cosine of theta and tangent of theta using trigonometric identities. A. To find the value of cosine of theta, you can use the Pythagorean identity. So sine squared of theta plus cosine squared of theta is going to equal 1. So 0.6 squared plus cosine squared of theta equals 1. Cosine squared of theta equals 1 minus 0.6 squared, which would be equal to 0.64. We then must take the square root of both sides, and we get that the square root of 0.64 is equal to 0.8. Now that we know the sine and the cosine of theta, using the quotient identity as tangent of theta is equal to sine of theta over cosine of theta. So 0.6 divided by 0.8, which is equal to 0.75. Use the definition of cosine of theta and tangent of theta and the triangle shown in figure 1.30 to check the result. You know that 0.8 squared plus 0.6 squared is going to be equal to 1. Using trigonometric functions with a calculator. In the last section, we found a lot of the trigonometric functions using the unit circle. So what if we have values that are not one of the ones on our unit circle? Unit circle are very common values of radians and degrees that are used, but sometimes we want to know the trigonometric functions at ones that are not on the unit circle. So if that is the case, we need to use our calculator. So to use a calculator to evaluate trigonometric functions of angles measured in degrees, you must first set the calculator into degree mode and then proceed. For instance, you can find the values of cosine of 28 degrees and secant of 28 degrees as follows. So in degree mode for both, to find cosine of 28 degrees, you can hit cosine 28, enter. For secant of 28 degrees, make sure you're in degree mode. You can hit cosine of 28 and then the inverse sign and enter. You can also do 1 divided by cosine of 28. Throughout this text, angles are assumed to be measured in radians unless there is a degree sign. So sine of 1 means that you're taking the sine of 1 radian. Sine of 1 degree means that you're taking the sine of 1 degree. This is very important because the two different things will give you completely different answers. Applications involving right triangles. So many applications of trigonometry involve a process called solving right triangles. In this type of application, you're usually given one side of a right triangle and one of the acute angles and are asked to find one of the other sides, or you were given two sides and asked to find one of the acute angles. In example 7, the angle you're given is the angle of elevation, which represents the angle from the horizontal upward to an object. For objects that lie below the horizon, it's common to use the term angle of depression, as shown in these figures. So if you have an horizontal and then the angle comes up, it's considered an angle of elevation. If you have a horizontal and the angle goes down, it's considered an angle of depression. So here's example 7. A surveyor is standing 115 feet from the base of the Washington Monument as shown in figure 1.33. The surveyor measures the angle of elevation, so from the horizontal upwards to the top of the monument is 78.3 degrees. How tall is the Washington Monument? So we know how long this side of the triangle is. We know the angle. We can use that information to find how tall the monument is. So thinking about what we need, we have this angle, we have the side adjacent, we have the side opposite. The trigonometric function that deals with the opposite and the adjacent is tangent. So we know that the tangent of that angle, the 78.3 degrees, is equal to the opposite of the adjacent. We also know that the adjacent side is 115, and that y is what we're trying to find. Y is equal to x times tangent of 78.3 degrees, or 115 times 4.82882. So approximately we get that the Washington Monument is 555 feet. I hope that our continual trigonometry, you are starting to learn a little more and remember how these 6 trigonometric functions work and how they work with unit circle, how they work with right triangles, how to tell the difference between radian and degrees, and we will continue to learn more and more. But I hope that you are enjoying your study and can't wait to teach you some more.